Welcome to today's video on mixtures. Before we get into this video, I would like you to like this video and share this video amongst your friends who want to learn this topic and also make the most out of the past 5 years questions. So what's in today's video? In today's video, we'll be looking at all the past 5 years questions which I've divided in the form of concepts. So for each and every question, I'll be taking you through all the concepts on how to attack the questions, and also will tell you the tips and tricks on how to solve them in the least possible time. So please stay tuned till the end of the video so that you should be able to make the most of all the concepts and also learn them and ensure that you get good marks in the exams in case some question comes from this topic. Now, why is this topic very important? Now, this topic becomes very important because it's evident from this table that it's been seen that almost every year, in every slot, we have been seeing at least one question coming up from mixtures. Right, so this topic, according to me, is nothing but an application of ratios, and we need to understand a few certain things that we'll be discussing in certain questions. So, without any delay, let's get into the questions. Now, let's look at the first question here. The first question says a chemist mixes two liquids 1 and 2. 1 liter of liquid 1 weighs 1 kg and 1 liter of liquid 2 weighs 800 grams. If half liter of the mixture weighs 400 grams, then the percentage of liquid 1 in the mixture in terms of volume is what? Okay, now let's see. So in liquid 1, what is happening? In liquid 1, I have 1000 ml, right? So 1 liter, that is 1000 ml, weighs 1 kg, which is 1000 grams, right? So 1 ml will weigh 1 gram. So let me assume I'm taking x ml of liquid 1. If I take x ml of liquid 1, then I'll have how many grams? I'll have only x grams of liquid 1. Similarly, if I talk about liquid 2, what is happening here? So 1000 ml is going to give me only 800 grams, which means 1 ml is going to give me 0.8 grams. Now I'm told that half liter of the mixture. So if in the mixture I have x liters of liquid 1, that means I'll have 500 minus x ml of liquid 2. Clear? So x ml of liquid 1, so I'll have 500 minus x ml of liquid 2. So the actual weight of this would become 500 minus x into 0.8. Which will be how much, guys? That will be 400 minus 0.8x. Now this two combined together, that is x plus 400 minus 0.8x. Now this weighs how much? 480 grams. So very simple question to start off with. When I'm mixing two liquids, without any doubts, we just get into the questions here. So when I transpose, we get 0.2x is equal to 80, or we get the value of x is equal to 80 divided by 0.2. If I need to simplify my zeros, this becomes nothing but 800 by 2. 800 by 2 is going to be 400. That means 400 ml out of 500 ml is liquid 1, and I'm asked the required percentage. So that becomes 400 by 500 into 100, which gives me 5 ones and 5 20s. So 4 into 20, it gives me an overall percentage of 80%, and that is going to be our required answer. Clear? So very easy question to start off with. It appeared in CAT 2019 slot 1. Right? Now, can I have a shortcut to this? Yes, we can also apply allegations here. Let's understand how to apply allegations here. So, I can apply allegations in the form of, in 1, I have 1 liter of liquid gives me 1 kg. That means roughly I can assume that the conversion rate is 100%. In liquid 2, I have 100 ml gives me 800 grams. That means roughly 100 out of 80, 800 out of 1000 gives me how much, guys? 80%. So I can assume that in liquid 1, the conversion is 100%, and in liquid 2, the weight is to ml conversion is 80%, and the output gives me 480 grams out of 500 ml. So if I talk about the percentage here, 0000 gets cancelled. This is 596. So I have 96% once I mix both of them. So when I alligate them, I get the ratio in which I have mixed them. So this gives me 16, this gives me 4. 16 is to 4 is nothing but 4 is to 1. That means out of a total of 5 parts, 4 parts is liquid 1, and I'm talking about a percentage. So this becomes 5 ones and 5 20s. So 4 20s, you have 80% as the value or the percentage of liquid 1 in terms of volume. Right? So we can use both the methods, guys, but even if we do not know allegations, the best part here is we can solve this question with the help of the basic method, taking x and simplifying the required answer. Now let's look at this question, guys. Now this question says the strength of an indigo solution in percentage is equal to the amount of indigo in grams per 100 cc of water, which is simple, which is called percentage only. Now two 800 cc bottles are filled with indigo solutions of 33 and 17% respectively. Okay, so I have 800 ml, the cc of bottle, and indigo solution here is 33 percentage. So if I calculate out of 800 cc, the quantity of indigo here becomes 264, that is 33 percentage of 800. Clear? Now a part of the first bottle is thrown away. Now let me assume that x liters is thrown away. If I am throwing out x liters, the volume or the quantity of indigo solution will be 33 percentage of x, which will be 0.33x. So this part we are throwing off. Clear? And replaced by an equal volume. That means I am replacing with x more liters of bottle 2. Now bottle 2 has 17 percentage strength. If 17 percentage strength, then 17% of x will be 0.17x. So effectively what is happening, guys? Effectively we have 800 ml only, but the quantity of indigo solution is going to be 264 minus 0.33x plus 0.17x. Now the question says the strength of indigo in the first bottle has now changed to 21 percentage. Now how do I calculate the percentage concentration? Now always remember, if I am talking about percentage concentration of indigo, clear? Then it would always be the quantity of indigo divided by the total quantity of solution multiplied by 100. So here we know that the quantity of indigo is going to be 264 minus 0.16x divided by total quantity is 800 multiplied by 100, and this percentage given to me is 21 percentage. So this 0000 gets cancelled. So when we simplify, you have 264 minus 0.16x is equal to 168. Or we have 0.16x is equal to 96, or we have the value of x is equal to 9600 by 16. Clear? That's going to be how much? 600. That means 600 ml out of 800 ml is taken out from bottle 2, right? So I repeat, bottle 2 had 800, we removed x from bottle 2 and the value of x is equal to 600. So after removing this, the quantity remaining in bottle 2 is going to be how much, guys? Is going to be only 200 ml. So this is again a very basic question. All we need to understand is how to calculate the percentage of indigo in the given solution, and that will be our breaking point to get this answer. Now can I get this by allegations? Yes, we can also get this by allegations. So let's try to understand this by allegations. So by allegations, I have 33 percentage of liquid 1 and I'm adding 17 percentage of liquid 2 to get a mixture of 21 percentage. So this part becomes 4, this part becomes 12. That means 1:3 is the ratio in which I have mixed them. Now one part out of 4 parts represents bottle 1. 3 parts out of 4 parts represents bottle 2. And the total quantity we know is 800 ml or 800 cc. So 1 by 4 into 800 is 200 cc is bottle 1. 600 cc is bottle 2. Clear? So if 600 cc is bottle 2 here, that means out of 800 ml of bottle 2, we have taken out 600 cc of bottle 2 and given it to bottle 1. That means the volume left after the exchange in bottle 2 is going to be 200 cc, and that is going to be our required answer. So again, two very easy and similar questions which we could have done with the help of basic method as well as allegations. I repeat, even if you are not able to solve with the help of allegations, we should be able to solve the questions with the help of the basic methods. That is my job here. All I'm looking at here is to make you solve the questions in the easiest possible manner. Right? Let's move to the next question here. Now, if a certain weight of alloy of silver and copper is mixed with 3 kgs of pure silver, okay, so I'm not given how much of silver and copper do I have. The resulting alloy will have 90 percentage silver by weight. Now again, just before we get into this question, how do we calculate the percentage of silver? Percentage of silver can be calculated as the amount of silver that we have divided by total quantity of the alloy, clear, multiplied by 100. This becomes the way to calculate the percentage of silver, and that is what is given. 90 percentage is given to us. So let's keep this in mind. Now let's look at 90 percentage concept. So I do not know how much silver do we have. Let's say we have S silver, we have C copper, and then we are adding 3 more kgs of pure silver. Clear? So what is my total quantity here? So my total quantity here becomes S plus C plus 3. And what is the quantity of silver? The quantity of silver is S and 3 kgs. So if I apply in the formula, we get S plus 3 is the quantity of silver divided by S plus C plus 3 into 100 is equal to 90. 0, 0 gets cancelled. So what do we have here? We have 10S plus 30 is equal to 9S plus 9C plus 27. Or we have 3 is equal to 9C minus S. This is going to be the first equation that we are looking at. Now let's do the second equation. If the same weight of the initial alloy is taken. So let me again assume that I have S kgs of silver, C kgs of copper. Now I'm adding 2 kgs of another alloy. That means I'm just adding 2 kgs of an alloy. So this becomes my total quantity. Now what is the quantity of silver here? The quantity of silver will be S plus this 2 kgs of alloy has 90 percentage silver. So 90 percentage of 2, which will be 1.8. Clear? Now this results in 84 percentage silver by weight. So we can apply the same concept here, that S plus 1.8 divided by S plus C plus 2 is the total quantity, multiplied by 100 is equal to 84. So when we transpose the values, what do we get here? We get 84S, sorry, we get 100S. So we get 100S plus 180 is equal to 84S plus 84C plus 168. So when we transpose the values, we get 12 is equal to 84C minus 16S. If I divide by 4, I get 3 is equal to 21C minus 4S. So I have two equations. Both of them are giving me 3 is equal to 9C minus S and 3 is equal to 21C minus 4S. So if I equate both of them, I get 9C minus S is equal to 21C minus 4S, or we have 3S is equal to 12C, or we get S by C is equal to 4:1. So let me assume this is 4x and this is x. This is what we have from the given information. Let's try to understand what is asked in the question. The weight of the initial alloy, and we have taken S and C as the weight of the initial alloy, which means I want the value of 4x plus x, which means our job is to get the value of 5x. Clear? Now what else can I do? I can replace this in this equation. Let's try to replace this. 9 into x will give me 9x. Minus S value is 4x, which is equal to 3, which means what do we get here? We get the value of 5x is equal to 3. Let's not go by fractions there, because we are asked the value of 5x and we have 5x is equal to 3. That means our answer to this question here becomes 3. So not a difficult question again. Yeah, a bit of calculation intensive here, but all we need to understand is again how to calculate the percentage of silver in the alloy. And once we are able to calculate that, our job becomes pretty easy here. Let's understand this question now. Now this question says a glass contains 500 cc of milk, okay, and a cup contains 500 cc of water. Now this is the catch here. I have a glass and I have a cup. So let's maintain that. So we talk about glass here and we talk about cup here. So glass has 500 cc of milk and cup has 500 cc of water. Fine. Now from the glass 150 cc of milk is transferred to the cup, right? Which means from here this 150 is removed and I'm adding one more column of milk here and we are adding 150 cc of milk, which means what do I have here? So now the quantity of milk here is only 350, whereas the quantity of water here is 500 and the quantity of milk here is 150, which means I'm mixing them in the ratio of 10:3. Clear? Because this is 0 0 gets cancelled, 5 tens are 5 threes are. Now why did I write the ratio? Because whenever you have a mixture, this is a simple concept we need to understand, that if I am taking out any quantity of liquid from this mixture and let's say transferring to the glass, it will always be in the ratio in which we have mixed them. So whatever quantity we take out should always be in the ratio of 10:3. Clear? Now what is the question talking about? Now 150 cc of this mixture is transferred from the cup to the glass, which means 10/13 of 150 will be the value of water that is transferred to the glass. That means I'm adding water column here. So water's column is going to be 10/13 of 150. And milk would be, so subtracting, milk would be 3/13 of 150. This is the concept of mixtures. Whatever quantity you take out should be in the ratio in which they have already been mixed. So the milk here becomes plus 3/13 of 150. This is what is happening now. The amount of water in the glass and the amount of milk in the cup are in what ratio? Fair enough. So if I simplify this, so water in the glass is 10/13 of 150. Now milk in the glass, I can take 150 common. This becomes 1 minus 3/13. Now 1 minus 3/13 is 10/13. So you have 10/13 of 150 is 2. Here also we have 150 into 10/13. So 10/13 and 10/13 and 150 will get cancelled. That means our final ratio will be nothing but 1:1 should be our required answer. So very easy question, depending on the base concept of mixtures, that from the mixture, whatever quantity of solution that we remove should always be in the same ratio in which we have mixed them, and rest of the part is all about calculations. Once the calculations are done, you are good to crack a good CAT level question and grab 3 marks in the examination. Let's look at this question, which is a similar question. Now there are two containers of the same volume. First had half filled with sugar syrup and the second had half filled with milk. Okay. So let's talk about first container and second container. So we are talking about sugar syrup and milk. Again, the question is talking about transferring. So this has milk and sugar syrup. That is SS. Okay. One second. Yep. So let's not get confused there. So half filled, right? So let's take roughly 500 ml or 500 x ml. So half filled by, or let's take 100x. Half filled is 100x. Okay. By sugar syrup, and the second one is half filled with milk. So again, this is going to be 100x. Now half of the content of the first is transferred to the second. So simple concept here. So minus 50x plus 50x. So after the first experiment, we have 50x here, and we have 100x and 50x. That means total is how much here? Total is 150, and I'm mixing them in the ratio of 2:1. Clear. So this is the total column. Now half of the mixture is again transferred back. That means now I'm removing 75 from here, which should be in the ratio of 2:1. So 75 in the ratio of 2:1, that is 3 parts. So 3 parts is equal to 75. So 1 part is equal to 25. So milk would be 50x and sugar syrup would be 25x. That means sugar syrup I'm adding back is 25x and milk I'm adding back is 50x. So after the second experiment, what does the figure look like? The figures look like 75x and 50x, and this is going to be 50x and 25x. So the total is going to be 75x. This is how the numbers look like. Now I'm told that next half of the containers of the first are transferred to the second. Now the total in the first is 125. So half of this will become 62.5x. Now 75 is to 50. This is 25 threes are 25 twos are. That means they are mixed in the ratio of 3:2. So 3 by 5 of 75 is gone. Sorry, 62.5 is gone. And this is 2 by 5 of 62.5 is gone. Similarly here, you have 2 by 5 of 62.5 which is being added here, and this is 3 by 5 of 62.5 which is being added here. Now let's understand what is the question asking us. Now the question is asking us that find the ratio of sugar syrup and milk in the second container. That means we want these values, only these two values. So this is 5 into 12.5. Now 2 into 12.5 will give you 25. 50 plus 25 will become 75x. This is 5 into 12.5. Now 3 into 12.5 is 37.5. 25 plus 37.5 will give you 62.5x. So when the ratio of sugar syrup is to milk, that means our required ratio is 62.5x divided by 75x, which is nothing but 625 divided by 750. Now this is 25 into 25s and 25 into 30s. 25 by 30 will eventually give me 5:6 as the final ratio, and therefore option A becomes our required answer. So what is the learning from these kind of questions, guys? So the learning from these kind of questions is pretty simple, that these kind of questions will be a bit calculation intensive. You have to be very clear in what ratio they are being mixed. Be very clear in what are the values that you're transposing to the other table, and then make these kind of tables and get your answer. You should be able to grab 3 marks for yourself in the examination. Right? Let's move to the next question. Now this question says the strength of a salt solution is P percentage if 100 ml of the solution contains P grams of salt. Okay. Each of the 3 vessels A, B, C contain 500 ml of salt solution. Okay. So let's say we talk about A, we talk about B, and we talk about C. So A has 10% strength, B has 22% strength. Let me give a bit of gap here, 1 second, because we'll need some space to write them. So let's say B has 22% strength and C has 32% strength. So let's say, so we have 500 ml. So the quantity of salt here becomes 50. Similarly, here you have 500 ml and the quantity of salt here becomes 110. That is 22% of 500. And here also the quantity of salt is 500 ml and the quantity of salt becomes 32% of 500, which is going to be 160 ml. Now 100 ml of vessel A is transferred to vessel B. So total quantity taken out is 100. So the quantity of salt will be 10% of 100, which is 10. And that 100 is transferred here. and the quantity of salt is also being added here. So what happens at the end of first experiment? So at the end of first experiment, this is 400 and we have 40 ml of salt. Clear? This is 600 and we have 120 ml of salt. Now 120 by 600, mind it, that's 20%. We'll keep that in mind. So now suddenly the salt solution of B, the salt concentration of B has become 20%. Now 100 ml of B is transferred to C. So C is as it is here, 500, and this is 160. Now if I'm taking out 100 from this solution, now this solution has 20% salt concentration. That means 20% will be removed, and that 120 will be transferred to this container. Now after the second experiment, let's understand what all do we have. So you have 400, this is still 40, this is 500 and this is 100, that is 20%, and this is 600 and that becomes 180. Now understand, 600 and 180, 180 by 600 is 30%. Okay. Finally, 100 ml of C is transferred back to A. So if I'm taking out 100, 30%, that is 30% of 100 will be removed. So I add back 100 and this becomes plus 30. So what is happening in A? I have 500 ml and now I have 70 ml of salt. The percentage strength of salt in A. So percentage strength of salt is simple. That is the quantity of salt divided by the total quantity multiplied by 100. 0000 gets cancelled. This is 5 ones are 5, 5 14s are. So therefore the strength of salt in A is going to be 14%. Clear? So that's going to be our required answer here. Let's move to the next question. Now this question says a mixture contains lemon juice and sugar syrup in equal proportion. Okay, so let me say lemon juice and sugar syrup, x liters of lemon juice and x liters of sugar syrup. That means a total of 2x liters. If a new mixture is created by adding this mixture and sugar syrup in the ratio of 1:3. Now understand, if one part is 2x, then 3 parts will become 6x. Now this 6x is nothing but sugar syrup solution. So I'm mixing both of these, right? And then find the ratio of lemon juice and sugar syrup in the new mixture. So lemon juice is x, sugar syrup becomes x plus 6x,